Hey everyone, welcome to homework 6.6. Today we looked at a little bit more with the MAD and then also with standard deviation, which again, you should know kind of how that formula looks, but you don't need to have that memorized and you can use your calculator to find it, okay? So here is some different cities and their temperatures. You might recognize Christchurch, New Zealand from 6th grade science. You remember that? Cool. Anyway, the low temperatures in degrees Celsius for some cities on the same days in March are recorded in dot plots. So these are the temperatures in March for these cities. Decide if each statement is true or false. Explain your reasoning. So 1, the standard deviation of Christchurch's temperatures is 0 because the data is symmetric. So the standard deviation, remember, is the difference between every value and let's see what's going on here. Here we go. Between each value and then the mean of that. And so even though this is symmetrical, there is a difference between each of these values and the mean. So it would not be 0 unless the temperatures were all the same, right? So this is false, right? That standard deviation would probably be pretty small because the data is symmetrical, but it is not going to be 0. So false, because the values of each data point have a difference from the mean that is not 0, right? So some of them might have a difference of 0, but a lot of them will not. All right, 2, the standard deviation of St. Louis's temperatures is equal to the standard deviation of Chicago's temperatures. Okay, so let's look at St. Louis and Chicago. So St. Louis is here, Chicago is here, right? Now, the standard deviation of this, right, if we look at where the mean is and where the mean is of Chicago, the values are lower, right? But the distance from the mean and from each of these values is probably going to be the same because notice that the distribution of the data is exactly the same. We have 1 value, 3 values, 1, 1, 5. 1 value, 3 values, 1, 1, 5, right? So the distribution of data is the same. It's on a different place on the, number line or the scale of temperature, but that difference of each of those values from the mean is going to be the same. And so the standard deviation is going to be the same because the distribution is the same. True, because the distribution of data is exactly the same. All right, number 3, the standard deviation of Chicago's temperatures is less than the standard deviation of London's temperatures. So Chicago and London, we're comparing these two here. So Chicago and London, interestingly, has a very similar, right, pattern. Chicago and London's distribution is almost the same, except that London has this outlier out here. And that's going to make this London standard deviation is going to be greater than Chicago's, right? So it says the standard deviation of Chicago's temperatures is less than the standard deviation of London. That is true because London has a data point that might be an outlier, we'll find out tomorrow, that we can say is far from the other or the bulk of the data points. All right, let's take a look down below. So use the space below to show your work. You may use a calculator. So the data represents the number of cans collected by different classes for a service project. So we can use a calculator, so I'm going to use a calculator for this one. And hold on, give me a second. All right, so let's go ahead and input this data. 12, 14, 22, 14, 18, 23, 42, 13, 9, 19, 22, 14. Now, you do not have to put the data in order if you're entering it into the calculator. You can if you want, if you need to find the mode or something like that, you can, but the main thing is you want to make sure you just put all your data points in. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 data points. I have 12 data points here. All right, so find the mean. So again, I'm going to go to Stat, over to Calculate, One Variable Statistics, and List 1. And so my mean is 18.5. My median is 16. And it says find the IQR, so that's 22 minus 13.5, which is going to be 8.5. 8.5. And then the standard deviation. So the standard deviation, again, we're looking at population. Standard deviation is 8.27. We'll round to the nearest hundredth in most cases. It says eliminate the greatest value, 42, from the data set. How does the mean change? So let's go back to Stat, Edit, go back to this list, and we're going to delete that 42. Okay. And I pressed the delete button there to kind of bump everything up there. Then we're going to go Stat, Calculate, One Variable Stats. Let's calculate. Ooh, whoops. I think I pressed a little too many buttons. There we go. All right, here we go. So now the mean is, it is lower, right? It's now 16.36. And so it's lower than it was before. The median is 14, so it also went down. Now notice though that the IQR is still about the same. It's only half a point off, so we have 22 minus 13, which is going to give us 9. All right, so the standard deviation here is 4.4, we'll round to 4.46, and so it goes down quite a bit, actually, right? This went from 8.27 to 4.46. So notice the thing that is most stable here is that IQR. And so that shows you that even when the data is skewed with a higher number, the IQR gives a good representation of how spread out that data is. What had the greatest change and why? So it looks like the greatest change was the standard deviation, right? And so the standard deviation, because of the change in mean, right? So if we go back here and we look at this data, right, if I were to add, right, if I were to add that 42 back in, right, and then I go to Stat, Calc, right, the mean changes, right, quite a bit there as well. And so because of that change in mean, the standard deviation is also going to change. All right. Let's take a look at this next problem. So the next problem is a continuation of a CAPE problem that you looked at before. For a school project, 2 students, Shona and Miguel, recorded the number of text messages each of them sent for a 60-day period. The box plot summarizes the recorded data. So select the drop-down menus to correctly complete the sentence. Approximately what % of Miguel's data values are greater than the median of Shona's? So Shona's median is here. Miguel's data has the second part, the third part, and the fourth part to the right of that. So only 25% of his data is less than her median, which means that 75% of his data is greater than. Most of his data is going to be in these 3 quartiles, right? After the first quartile, after the median, and after the third quartile, right? That he's going to have all of that data is after her median. So more than or 75% of his data is greater than her median. So here's the same project, right? Part C says select all that apply. So for approximately 15 days, Miguel sent 50 or more text messages a day. Well, remember that this is over a 60-day period. All right, so remember we're out of 60 days. And Miguel sent 50 or more text messages. Well, 50 here would be the last quarter of his data. So a quarter of 60 is 15. So that checks. For at least 5 days, Shona sent 55 or more text messages per day. So Shona, we can't actually tell, right? We see this little part here, but that data could be spread along this line anywhere. So we don't necessarily know that that's true. It could be, but we don't know for sure. There was at least one day on which Shona sent 40 text messages. So again, we don't know because she has data between 35 and 45, but that might mean that she has 41 and 39, right? We can't tell specific data points on a box plot. D, the number of days on which Shona sent more text message than Miguel is greater than 30. Okay, so she sent more text messages than Miguel. So again, it's out of 60 days, and most of her data is actually less than Miguel's. So that doesn't make sense because 75% of his data was greater than her median, right? So that seems unlikely that half of the days she sent more text messages than him. And then E, Shona and Miguel each sent 25 text messages on the same day. Again, we cannot tell, right? They both sent 25 text messages at some point, but we don't know if it was on the same day. It could have been any one of those days in that 60-day period. So this is a tricky one because it says select all that apply, but the only one that really applies that's true is A. For part D, it says there are different methods of identifying outliers in the data set of values. One method is described. Multiply the interquartile range by 1.5. We're going to learn more about this tomorrow. Add the result to the third quartile to determine the upper limit, and subtract the result from the first quartile to determine the lower limit. Any value greater than the upper limit or less than the lower limit is considered an outlier. This is going to be our definition of an outlier as well. On the 61st day, Shona sent T text messages, which will be considered an outlier based on the described method. What number could be the value of T? So first we need to look at her interquartile range. Her interquartile range is 15. So 15 times 1.5. So let me get out of this. 15 times 1.5 is 22.5. So if we add 45 to that, that gives us our upper, right? Anything above 67.5 is going to be an outlier. So that means that 75 is going to be an outlier. And then her lower quartile, her first quartile is at 30, right? So 30 minus 22.5 gives me 7.5. So anything less than 7.5 would be an outlier. So 5 is also an outlier on this end, right? If we had a value down here at 5, that would be an outlier. And if we had something all the way up here at 75, that would also be an outlier. Okay, so again, we're going to go over this and practice this more tomorrow, but this is a little preview of how to do that. If you need any help, please let me know. Please continue to work on your park released items, your park packet for spring break, so that you don't have spring break work. I will upload a few more videos tonight. Your code word for today will be T-Mobile. T-Mobile is your code word for today since we talked about text messages. Happy homeworking and see you tomorrow.